Hello, I am Saket. My topic in analog and digital electronics is two-dimensional nanomaterials in thermal management applications. So let's go into the topic. Importance of thermal electromagnet in electronic devices. Nanospectroscopy is a powerful imaging technique used to study the properties of materials at which the nanoscale level. It involves the use of near field scanning, optical microscopy NSOM, and tip enhanced Raman spectroscopy TERS to obtain high resolution images and spectra of semiconductor materials. So this was the importance of magnetic magnet management on electronic devices. So now let's go into the another slide. Nanospectroscopy imaging techniques for semiconductor materials. Near field scanning, optical microscopy NBOM. Near field scanning, optical microscopy NSOM is a microscopy. NSOM is a powerful imaging technique that allows for the observation of semiconductor materials at the nanoscale. The NSOM uses a small aperture probe to scan the surface of the sample, creating images with resolutions beyond the diffraction limit of light. This material at the nanoscale applications in semiconductor material imaging NSOM has many applications in the imaging of semiconductor materials. It can be used to study the optical and electronic properties of materials as well as their surface morphology, and NSOM can also be used to study the behavior of individual molecules and their interactions with the material surface. This makes it an invaluable tool for researchers and engineers working in the semiconductor industry. For more clear explanation, you can look at the image A and B of nanospectroscopy imaging technique. So these was the techniques, and now let us go into the another slide for more information. These are the properties relevant to thermal management. High thermal conductivity. Learn how two-dimensional nanomaterials excel in conducting heat, enabling efficiency and magnet management. Low dimensional thickness. Discover how the ultra thin nature of the materials allow for effect heat Dissipation in compact devices. Excellent mechanical flexibility. Understand how the flexibility of two-dimensional nanomaterial enhances their thermal management capabilities. So these were the properties relevant to thermal management. Now let us look after the applications in thermal management. The applications are thermal interface materials. You can look after the images. Thermoelectric devices, heat sinks, and flexible electronics. So these were all the application in thermal management. Now let us look after the advantages in thermal management. Explore how the flexibility of two-dimensional nanomaterials enables their integration into various devices, architecture, surface, plasmon response, SPR, NSOM, and TERS can be used to measure the surface plasmon resonance of semiconductor materials, which provides insight to their optical properties and electronic structure. Nanoscale defect detection, NSOM and TERS can be used to detect nanoscale defects in semiconductor materials, which is important for quality control and improving device performance. Doping profiling, NSOM and TERS can be used to profile the doping concentration of semiconductor materials, which is important for the optimizing devices performance. Surface morphology, NSOM and TERS can be used to study the surface morphology of semiconductor materials, which is important for understanding their physical and chemical properties. Now let us go through the challenges and limitations. Thermal stability of polymer defined as the ability of a polymeric material to resist the action of heat and to maintain its properties such as strength, toughness, and elasticity at given temperature. And large scale production, mass production in the manufacture of large quantities of standard products, often using assembly line or automation technology. Mass production facilities effect production of a large number of similar products. And material compatibility, material compatibility refers to the material resistance to corrosion, rust, and stains come in contact when it comes in contact with chemicals. Future prospects and advantages. Advancements in NSOM TRS technology are expected to improve the resolutions and sensitivity of imaging techniques. Research of ongoing to develop new probes and tips for NSOM and TERS that can provide even higher resolution and sensitivity. The use of machine learning and artificial intelligence in data analysis is expected to enhance the accuracy and speed of image processing. Further research is needed to fully understand the underlying physics of NSOM and TERS imaging, which could learn to new breaking thoughts and applications. These are the benefits of nano imaging techniques. One is improved resolution and one is chemical mapping. Now let us come to the conclusion of the topic. The rapid development of the nanoscale spectroscopy imaging has been impressive in recent years. The development and incorporation of the new hardware has produced new techniques, and the competition between commercial companies appear to be producing instruments which increases accessibility of known specs. Today, it is common for the instrument manufacturer to set up demonstration at conference exhibitions and travel with functioning instruments. The current challenge appears to be choosing the flavor of nanospectroscopy imaging will address a specific. uh, Thank you.